Hello everyone, I am BIPAN SAMAL, Faculty of Geography and Environment. In this session, I am going to discuss an important topic of climatology, that is cyclone. So before start our discussion, let's take an overview. What are the things that we are going to discuss in this session? So in this session, I am going to discuss about cyclone. Under that, we'll discuss what are the meaning of cyclone. Then we'll cover what are types of cyclone. As you know, there are two types of cyclone. One is tropical cyclone and another is temperate cyclone. One is tropical cyclone and second is temperate cyclone, or it is also known as extratropical cyclone. But in this session, I am going to discuss only about tropical cyclone. Under that, first we'll try to understand what are tropical cyclone. Then we'll see what are the conditions required for the formation of tropical cyclone. What are the conditions required for the formation of tropical cyclone, and we'll see the structure of tropical cyclone. Structure of tropical cyclone, and lastly we'll see why east coast of India, especially in the state of Odisha, Andhra Pradesh and West Bengal, east coast of India is more prone to the tropical cyclone. More prone to tropical cyclone. So let's start one by one. So first we'll try to understand what are cyclone, then we'll discuss tropical cyclone, what are tropical cyclone, then the condition required for the formation of tropical cyclone, then structure of tropical cyclone. So first try to understand what are cyclones. As we generally know that cyclones are related to rainfall, and we experience rainfall when there is low pressure created over the ocean. So can I say cyclones are nothing but they are low pressure center, and this low pressure center is surrounded by closed isobar. Closed isobar means an area having equal pressure, and this low pressure area is surrounded by closed isobar with increasing pressure outwards. If the center of cyclone, that is low pressure, is 900, let's say for example 15 MB, then the pressure will increase as you move from the center of cyclone toward the outer area. So here the pressure can be 920, here the pressure can be 925 MB, and here it can be 930. So can I say if the center of cyclone is low pressure, that is 915 MB, the outer area of cyclone is high pressure area. So this can be high pressure area, this is also high pressure area, and this is also high pressure area. Now as per the law of wind, the wind says that wind move from outside high pressure to center low pressure in such a way that if it is northern hemisphere, let's say for example this is the northern hemisphere, and if the same cyclone originate in southern hemisphere, let's say for example this is the low pressure area, and this low pressure area is surrounded by closed isobar with increasing pressure outwards. So can I say this is the high pressure area, this is also high pressure area, this is also high pressure area, and this is also high pressure area. But the only difference is it is in northern hemisphere, it is in the southern hemisphere. Now, as we discussed, the law of wind says that wind move from outside high pressure to central low pressure in such a way due to Coriolis effect. The wind which move from outside high pressure to central low pressure will deflect toward the right. Similarly, wind deflect toward the right from outside high pressure to central low pressure area. And due to Coriolis force or Coriolis effect, similarly, in the southern hemisphere, it will move toward the left. It will move toward the left. Now, what are the cyclones? Can I say cyclones are low pressure center? This low pressure center is surrounded by closed isobar with increasing pressure outwards. As per the law of wind, the wind says that wind flow from outside high pressure to central low pressure area in such a way that wind deflect anti-clockwise in northern hemisphere, and can I say this is clockwise in the southern hemisphere. So this is the basic meaning of cyclone. So in this session, we understood so far the meaning of cyclone. Now, there are two types of cyclone. The first is, as we discussed in previous slide, that is tropical cyclone, and second type of cyclone is known as extratropical cyclone, or we can say it is temperate cyclone. But in this session, I am going to focus upon only about tropical cyclone. These tropical cyclones, it flows between 10 degree north to 30 degree north and 10 degree south to 30 degree south. And extratropical cyclone which flow between 35 degree north to 65 degree north, and in southern hemisphere it is flow between 35 degree southern hemisphere to 65 degree southern hemisphere. Now we'll discuss about tropical cyclone. So what are tropical cyclone? As the name says that tropical region, generally we say the tropical region are region between 0 to 23.5 degree northern hemisphere and 0 to 23.5 degree southern hemisphere, but technically it is incorrect. The tropical region are only about 10 degree north to 30 degree north and 10 degree south to 30 degree south. Between 0 to 10 degree north or 0 to 10 degree south, it is known as equatorial region. So tropical cyclones are most dangerous. They are most dangerous atmospheric disturbance that are developed. These atmospheric disturbance are developed only in tropical ocean and seas. Remember the things, the tropical cyclones do not originate over the land. And the second thing is, these tropical cyclones which are originate only in the tropical sea or ocean, these tropical cyclones are associated with a release of moist heat as well as, or we can say, and it require higher value of Coriolis force. What are the things that we'll discuss when we'll discuss condition required for the formation of tropical cyclone? So it is associated with the release of moist heat and higher value of Coriolis force. And these are things, both release of a moist heat and Coriolis force, or we can say Coriolis effect, these are formed due to convergence of several warm air masses. Now these tropical cyclones are known by different name at different location, and based on their location, let's say for example, the tropical cyclone which are originated in Gulf of Mexico or Caribbean Sea, they are known as hurricanes. If the same cyclone originate in the tropical area, means Indian Ocean region, they are known as cyclones. If it is originate in the Indian Ocean region, it is known as cyclone. If the same cyclone originate in Australia region or northeast of Australia, it is known as Willy Willy. If the same cyclone originate in the South China Sea or it further extend toward the Japan region, it is known as typhoon. So if it is originate in South China Sea, it is known as typhoon. And if typhoon become intensive and it reach up to Japan region, the same cyclone is known as typhoon. So these are some name of tropical cyclone at different location. Now, based on their high destructive potential, means based on their high speed of wind, they are further divided in different names. Say for example, this is the first stage of development of cyclone, stage 1. So it depends on the speed of a wind. If the speed of a wind increase, is 60 km per hour, it is known as depression of cyclone. And further, if the speed is further increasing, means 60 km to and reach up to 120 km, this is known as, this cyclone is known as cyclonic storm. And further, if the speed of wind increasing, means from 120 km to it reach up to 240 km, that is the third stage of cyclone, that is 120 km. It crosses 120 km per hour and reach up to 240 km per hour. This cyclone is known as cyclones. And further, if the speed of the wind increases and it reaches up to the 240 km per hour, or you can say greater than 240 km per hour, this is the fourth stage of cyclone. Greater than 240 km per hour. This cyclone is known as super cyclone. Super cyclone. So based on their high destructive potential, we understood the cyclone are known by different name. Now we'll see what are the conditions required for the formation of tropical cyclone. So let's try to understand. Condition for tropical cyclone. What are the conditions required for formation of tropical cyclone? Now the first condition that required for the formation of tropical cyclone is, let's say for example, this is the land area and this is the continental shelf, then this is the water body. This is the continental shelf, then continental slope, then continental rise, then we have abyssal plain also. This is the land area and this is the sea or ocean. So as we see, you can say this is the side view of tropical cyclone. This is the side view. And in previous slide, we have seen this is the top view of tropical cyclone. Top view of tropical cyclone. Now, when talk about condition for the formation of tropical cyclone, we understood that tropical cyclones are associated with the rainfall, and we experience rainfall when there is low pressure created over the ocean. So can I say if there is low pressure created over the ocean, and this low pressure, can I say it's surrounded by closed isobar with increasing pressure outwards, and this is the high pressure zone, and this can be your high pressure zone. And as per the law of wind, the wind says that the wind flow from outside high pressure area toward the low pressure area. Now why it is low pressure created over the ocean? Because this is the most temperature region in this surrounded area. Now if it is low pressure area, so the air become lighter, and when the air become lighter, it has capacity to absorb or to trap more moisture from the more water from the ocean. So the air become lighter, it start rise up. So it started rise up. So can I say the first condition that require for the formation of tropical cyclone is they are developed only in the region. They develop only in the region when there is warm sea surface. Developed in the warm sea surface, having temperature greater than 27 degrees Celsius is required. Now this warm air masses, or we can say lighter air masses, as it rise up, it started condense. When this warm air, moist air started condense, it released some heat. And when it releases some heat, the low pressure will intense. And once this low pressure will intense, it will absorb, until it will pull the air from the high pressure. So it releases some heat. When it releases some heat, this heat is known as latent heat of condensation. So the second condition that required for the formation of tropical cyclone, so can you say this is the first condition and this is the second condition, that latent heat of condensation is required. Latent heat of condensation, and this latent heat of condensation is the source of energy or driving agent of the tropical cyclone, and hence these the tropical cyclones are originate only in the sea where there is abundant moist heat present. Moist heat present. Now reaching certain height, after reaching certain height, there is high pressure zone at the upper atmosphere, and from the high pressure zone, it will not further rise up, it will deflect toward the different direction due to Coriolis force. So in previous slide we seen due to the Coriolis force the wind deflect toward the right in the northern hemisphere and left in the southern hemisphere. So the third condition that require for the formation of tropical cyclone, can I say it require high value of Coriolis force, value of Coriolis force. Therefore, Coriolis force. Therefore, the tropical cyclones do not originate between 0 to 5 degree or 10 degree north and 0 to 5 degree south and 10 degree south. Why the Coriolis force is 0 at that equatorial region. So therefore, tropical cyclone do not originate in equatorial region. Now the fourth condition that require for the formation of tropical cyclone, that is these tropical cyclones are associated with ITCZ. What are ITCZ? That is intertropical convergence zone. So ITCZ are zone because of ITCZ, due to convergence of ITCZ, because in the region of ITCZ there is convergence of several warm air masses. Because it requires ITCZ, therefore, when the ITCZ is shift away from the equator, especially, say for example, this is the equator, this is the equatorial region, and when the ITCZ is shift away from the equator, especially in the month of September, October, November, December. So in the month of September, October, November, December, the ITCZ is shift toward the southern hemisphere, and that time the tropical cyclones are originate in between the Bay of Bengal region or Arabian Sea. And the thing is what, when ITCZ shift toward the southern hemisphere, the tropical cyclone, the ITCZ does not shift in the region of the ITCZ does not shift in the region of west coast of South America. So this is the South America, this is the Africa, and we have Australia. So remember the thing, the ITCZ does not shift in the region of west coast of South America, west coast of Africa, and west coast of Australia. Why? Because due to the presence of cold current, and the name of the cold current is, that is Peru current, or we have Humboldt current. Next is we have Benguela current, and the next cold current name is West Australian current. West Australian current. So due to the presence of cold current, that is West Australian current, Pengula current and Humboldt or Peru current, these are cold current. Therefore, the tropical cyclones are not present in the west coast of South America, west coast of Africa and west of Australia. Now, so these are associated with the ITCZ. Now the next condition that required for the formation of tropical cyclone, there should be high pressure. There should be high pressure in the upper atmosphere. Due to the presence of high pressure, from the high pressure, the air will not further rise, the air will start descend in the wall. So at the high pressure area, the air will start descent. So these are the things we have discussed about the tropical cyclone, that condition required for the formation of tropical cyclone. Now we'll see what are the structure of the tropical cyclone. So if you see the slide, so we have understood what are tropical cyclone, what are the conditions required for the formation of tropical cyclone. Now we'll see the structure of tropical cyclone. So when I talk about structure of tropical cyclone, structure of tropical cyclone. So if you see previous slide, the diameter of tropical cyclone, the first thing is diameter. So diameter means from center to the outer area. So first thing is diameter of tropical cyclone. It varies from region to region. If we say it depends on the speed of the wind and location, the speed of wind is greater, so it can extend far away from the equator, and it can be extend far away from the equator, high pressure. So it depends on the speed of the wind. So it varies from region to region. So from center to outer area, it varies from region to region. It extends from 30 kilometer to 300 kilometer. 30 kilometer to 300 kilometer the diameter. Now second thing is the height of the tropical cyclone. So the height of tropical cyclone means from sea to upper atmosphere. So if you see the height of the tropical cyclone, it also depends on the speed of the wind. So the height is vary from region to region. Can I say? So the height will be around 15 kilometer from sea level. Now after diameter and height, you can say, if you see at the center of the cyclone, so this is the spiral movement of cyclone. So can I say at the center of the cyclone, this zone is low pressure area, and when this low pressure area, there is no rainfall occurs in between the low pressure area, and this low pressure area is rainless, cloudless area, which is known as eye of the cyclone. So can I say the next thing is center of cyclone is low pressure area, and this low pressure area is rainless. This low pressure area rainless. This is also cloudless area, and this is known as eye of cyclone. Eye of cyclone. And due to above high pressure, can I say due to above high pressure, the air will start descend. When the air starts descend, the surrounding area, this is the surrounding area of the wall, this is the surrounding area, and this wall is known as, so there will, you will see the wall of the cyclone surrounding the wall. This wall is known as, so the fourth thing is the surrounding area surrounding the low pressure. The surrounding the low pressure, there is a huge wall. So you can say this is the huge wall of what type of clouds? This cloud is known as cumulonimbus cloud. Cumulonimbus cloud. So this is known as cumulonimbus cloud. And this cumulonimbus cloud surrounding wall, low pressure area, which is having cumulonimbus cloud. The last thing is of structure of the tropical cyclone, that is low pressure. And this low pressure, when get intense, more intense, a strong wave created, that is the most, that is known as most dangerous atmospheric phenomena, or you can say the most dangerous phenomena of the tropical cyclone is known as storm surge. So what is storm surge? So storm surge are nothing, they are developed due to increase in low pressure, or you can say in terms of low pressure. When low pressure increase further, the sea level rise, and when the sea level rise, a strong wave created. So if the low pressure further increased, if the low pressure further increase, further intense, so can I say the sea level rise will pull the sea level rise, and when sea level rise, a strong wave created, and this strong wave is known as storm surge. When this storm surge, when the cyclone travel from sea to land, the storm surge also travel from sea to land. When this storm surge will move sea to land, as a result, the sea level will rise. Sea level rise, and the negative impact of is, so can I say the coastal area will submerge. It will also affect the people. It will, can I say it will also affect the agriculture, fertile land, etc. Now, after the origin of tropical cyclones from sea or ocean, let's say for example, the tropical cyclones are originating in the Bay of Bengal region, or we can say Andaman Sea. So this is the India map. Say for example, this is the Bay of Bengal region, and tropical cyclone can originate in Bay of Bengal, or you can say Andaman Sea. So due to the trade wind, as you know, the wind in the tropical region move from east to west, and this is the Arabian Sea. Now, due to trade wind, the wind move from east to west. So tropical cyclone will also move from east to west, but they generally curve toward the north. Say for example, the tropical cyclones originate over the Bay of Bengal region, and second branch of tropical cyclone is originate over the Arabian Sea. So the tropical cyclone which originating in low pressure area, that is Bay of Bengal area, or we can say in Andaman Sea, they move from west to east, but generally they curve toward the north. When they generally curve toward the north, therefore this is the one reason why the east coast of India, especially in the state of Odisha, Andhra Pradesh and West Bengal, they are more affected due to they are more prone to the tropical cyclone. This is the one reason. Why? Because in the region, if you see, this is the one hills, second, third or fourth. So these are four major hills that is known as, the north is Palakunda, and second is south of Palakunda, that is Nelkonda, and south of Nelkonda is Jawadi Hills, and south of Jawadi Hills is Savoy Hills. So these are major hills in the east coast, and between the hills there is gap between the hills, that is Mahanadi Delta, Godavari Delta, Krishna Delta, and Kaveri Delta. So the people are settled in this delta region. Therefore, when the cyclone enter in this region, the cyclone which are originate in this region, the people are affected more. While the other branch of tropical cyclone which are originate in the low pressure area, that is Andaman Arabian Sea, they generally curve toward the east, and they generally curve toward the northeast region or north region, and it hit the west coast of Gujarat, and further when they hit the east coast of India, it further reach up to Pakistan, Oman, and Afghanistan also. So these are the some things, some point we have discussed regarding the tropical cyclone. Now the last thing, last dimension I'm going to cover about tropical cyclone, that is, we have seen the structure of tropical cyclone. The last point we'll discuss why east coast of India is more prone to the tropical cyclone. Now the first reason why the east coast of India is more prone to the tropical cyclone is, the first point we have already discussed. The reason number one why east coast is more prone to tropical cyclone. Tropical cyclone. The reason number one, try to understand. The reason number one, as I discussed in previous slide, the cyclone which are originate in Bay of Bengal, or we can say Andaman Sea. See, they direct hit the east coast of India. If you see, they direct hit the east coast of India, while the other branch of tropical cyclone which are originate in the Arabian Sea, they move away from the west coast and hit the, due to the general curve toward the north, they hit the west coast of Gujarat and Rajasthan region. So we can write one more point, that is, first point, Bay of Bengal and Arabian Sea, Andaman Sea branch hit east coast, while the other branch, that is Arabian Sea branch, this is away from west coast. Now the second reason why the east coast of India is more prone to tropical cyclone is the frequency of Bay of Bengal cyclone. If you see the east coast and west coast, so if you see this is the Arabian Sea and this is the Bay of Bengal region. So this is the Arabian Sea and this is the Bay of Bengal region. So if you compare Arabian Sea and Bay of Bengal region, so can I say the Arabian Sea is more open than the Bay of Bengal region? If the Bay of Bengal region is more closed, more enclosed to the land, so this area, this water body will become more warmer. Therefore, the frequency of tropical cyclone which are originate in Bay of Bengal is 35% greater than the Arabian Sea. So the second point is, second reason is Bay of Bengal cyclone is 35% greater than Arabian Sea. Now the last point why the east coast of India is more prone to tropical cyclone, because the Bay of Bengal is more connected to Pacific Ocean than the Arabian Sea. If you see Bay of Bengal, this is the Pacific Ocean, the east of Bay of Bengal or Andaman Sea. Because the Pacific Ocean is very close to the Bay of Bengal, the cyclone which are originate in the South China Sea, known as typhoon or typhoon in Japan, the remnant of typhoon or typhoon, they enter through the state of Malacca or other region, and they try to enter in Bay of Bengal region. And the cyclone which are originate in Bay of Bengal region, it become more intensive. So the next point is, the next region is the cyclone which are originate in South China Sea. They enter Bay of Bengal and the cyclone of Bay of Bengal become more. So this is how we have seen the important points we have seen regarding the cyclone. So you understood what are the cyclone, the meaning of cyclone, types. Then there are two types of cyclone: tropical cyclone, temperate cyclone. Temperate cyclone, also known as extratropical cyclone, that we'll discuss in next class. Then under tropical cyclone, we have seen what are tropical cyclone, what are the conditions required for the formation of tropical cyclone. We have also seen structure of tropical cyclone and why east coast of India is more prone to the tropical cyclone. In next video, we'll try to understand the extratropical cyclone or also known as temperate cyclone. Thank you.